Hello guys and welcome for this new tutorial. Last time we created the skeletal rig for the bunny, and after that we created the physical assets with the constraints for that character. Today we are at the end of this arc about the character, so we will be able to use the new feature physical control. So with the physical control we can actually change how the different bone will react in the physical environment. And the stuff that we want at the end is that the ear of the bunny will respond with the movement of the character, when it will get lunge, when it will jump, and everything. We want the ear to be able to kind of be in the physical way and move on his own. So let's go in Unreal. I will show you how it works. Okay, so we are back in Unreal. So I made some change. We will talk about that later. Just to have some gameplay, I will show you. But first, we need to add the physical control. So to add it, we need to go into plugins and we will type physics. And there is this physics control. It's experimental. So we'll enable this, we click yes, then we'll restart. Okay, so now that we have our physical control enabled, we can go in our blueprint, in our player blueprint, and in our player blueprint, we will add a new component. It's called physics control, this component. It will add a component into the character, physics control. It's that it's still experimental. We don't have to change anything in here, everything is good as default. And now we will use the physical control. So we'll get this physical control. So we'll use the create control and body modifier from limb bone. With this, we will be able to set up our physics. First, we will need the skeletal mesh. So we'll get our mesh. Up. Now we need some limb setup data, so we'll promote this to variable. We'll compile, and now we can add some setup data. For the limb, I will show you in our character, not the static mesh, and in the skeletal mesh. The limb will be some part that we want on our character. For example, we can have one limb will be the right legs, another limb will be the left legs, there will be left arm, right arm, there will be the left ear and right ear, the head, and the torso, the spine. So that's what we will set up. First, we will start with the ear, the left ear. The start bone will be, let me go in my skeletal mesh, will be this bone, ear 01 left. I will copy the name. Does it work? No, I will type it. Just be careful to put the good name, otherwise it will not work. So what this will do is that from this starting bone, it will get all of the bones. And this one, this one, this one, this one. We do the same for right ear. You cannot see, I will just go up. I will go there, it should be easier for you to see. Right ear, it should be ear 01 right, include parent bone. Then we will go into the head. So for the head, we will get the neck and the head. So if we create a limb bone from the neck, it should take everything that is above, so including the ear. But as we already specified that the ear, they have their own limb, it will not take it. It will take only the bones that are available. So if I choose that the neck is for my limb head, it will take the bone neck and the head, but not the both ear, because they're already in their own limb. So we will create a new one called head. Use neck, we don't have to include the parent bone, we don't care. Then we will need the arm. We need the arm, it will be from the clavicle left. So let's create a new one, call this left arm with clavicle underscore left. Another one, right arm, clavicle underscore right. Now we will create the legs first. left legs will be this bone. Underscore left. Create the right legs. Right leg. Okay, goes up. And now we need to have the spine. For the spine, we need to be careful because we don't want to start from the pelvis and not even from the spine one. If you put pelvis and spine one, there will be some issue. The character will do like crazy stuff. It's not gonna work. We will start from the spine 2. We'll put spine 2 and spine 3 in this limb bone. So we'll call this spine and we'll start by the spine underscore 2. Compile and save. And now we need to specify some settings. Now there is the world space control data. We will promote this to a variable. We'll compile and change the stuff. This is the stuff that we need to set up to control the reaction from our animation to the world. The stronger we put for the strength, the stronger it will try to be matching the animation. That's very important. To really understand it, we will make some tests. I will put the default value that I want to have, and then we will tweak it up and we will see what are the different. Save this. I put 3 in the linear strength and 3 in the angular strength. The world space control settings, we don't need to change it. We will check the enable world space control because we are using animation. The world space control is with the animation. We will set up some parent space control data, but we are not gonna use it. But still, we will set them up and we put 10 in the angular strength. The parent space, it's for to do a ragdoll. If you check the parent space, it will start doing the ragdoll stuff. But we are not gonna use that. The physics movement type we want simulated, and the gravity multiplier we'll put 0. Now we have all our controls that are created. And now we'll make some change. I will just use a sequence because now we put the same world space control data to all of our limb. But I want to change some because I want, for example, the feet to not be simulated by the environment. I want the feet to do the walking animation, otherwise it's gonna do crazy stuff. And I want the ear to be fully reacting to the environment. So that's what I will do. We'll start with the legs and we will add controls to set. So we'll get the get control name in set. And we want the set that this have created, which is world space underscore the limb that we have created. So this is the world space setup for a limb. So we can either put world space underscore all to change all to get the all the limb from the workspace, or we can specify one that we have created with the limb setup data. So if I go into the legs, we have, for example, left legs. So I can put world space underscore left leg, and I will have all the control there. I put them there, and I will put this in a new set that will be called world space underscore legs. To have a reference, I will put both of my legs into this set, and then I will be able to change the set workspace underscore legs to control both of my legs. I don't have to specify for one and then specify for the other one. So I will copy and paste this, put it there, and I will keep this, and this will be the right legs. Right leg. Now I can change the simulation, and we will do a set body modifier, set body modifier movement type. Put in the Zen one, and the name will be this name, the world space legs. and we want the movement type to be kinematic. Kinematic means that it's only gonna use the animation when simulated, means that it will use the animation but also try to react to the physical environment. So we'll put only kinematic for the legs. We just want the legs to be fully animated, and the rest will be a mix between the animation and the physics environment. We'll compile, and now we'll change for the ear. I'll put this up a little bit, and I will do the same thing. I will create a new set for my ear, and I will put both of them into the set. So I can copy this under, I will copy it here, and I will put it in the Zen 2. Then I will change this to left leg to left ear, this to right ear, and world space I will put ears, and this will be the world space ears. Okay, so now I have a new set that can control both of my ear. And now we'll change the world space data of the ears. We will set control data in set. I just this one. And I will split the control data. It will be easier to set it up. I will plug this into the Zen 3. And in the set, I will use the set that I've created for my ears. I will say that this is, I want to change the control data for my world space ears. For the value, I made some tests, and I really like to have one in the control data linear strength and one in the angular strength. Then I just want to change also my world space head, because I don't want it to be at 3, otherwise it will maybe move too much. It will be weird. I will put set control data in set. I will split this spin again. I will plug this here, and I will change this to world space underscore head. I will make sure that I choose the good thing. Yes. And for the control, we put 10 and 10 to be sure it doesn't move too much. And now we can compile and save. And we can now test it out. We're going to the game now. We can see that my character is actually moving with some physical stuff. We can see that you see my ear is responding to the movement of my character. And if I will just show you something I didn't show you at the beginning. If I unplug this, you will see the difference. Here is the animation without the physical stuff. We can see that the ear is very stiff. Everything is very, very stiff. And if I plug it back, here's the difference. The walking animation is maybe a little bit weird. We can maybe tweak it up a little bit, but the ear responds perfectly to my movement. So that's kind of cool. For example, if I go there, I can go in here and my ear reacts to the environment. If something blocks my ear, it's gonna move with the environment. That's pretty cool. For example, I can go and hide the wall, and we can see that the bunny reacts to the environment. There is the animation, the walking animation still working, but as there is something against him, it's reacting. I will show you the difference. It's a very subtle change, but it gives some life. To the character. For example, there, it's just doing his animation and not reacting to the wall. So that's pretty weird. It's going into the wall. It's not very good. And if I go there, the ear will just go into the cube. So it's not very realistic. If I go, for example, against this little hammer, I will get pushed. It's good, the animation is good because it's the falling animation. But if I add the physical response, if I plug this back, you will see that the body is gonna react to the fact that it got pushed. You will see it's pretty cool. If I go there, you can see that the ear and the body react that it got touched. And when it hits the wall, the ear and everything hit the wall. And we can have something a little bit more realistic. You see? With just this little change. That's pretty cool. You can see that the arm also reacts if I put myself against the wall. My arm gets attracted by the cube. That's pretty nice. The legs still looks a little bit weird because he has long legs. He has a long feet, so the feet sometimes get blocked with the floor. We can see that he's like dragging his feet. He's dragging his feet against the floor, but it's still pretty good. He's leaning toward the floor when he stops. The head comes back with his ear. It's actually pretty good. That's pretty funny when he's like walking against the wall. If you have a physical asset that like we have created in the last video, you can actually try this out and see how does it react with your character. You can see when I jump, the ear go down. It's pretty good. And it reacts to the environment. Like this. That's pretty good. So as I said in the beginning, I made some change. I created some stuff because we want to make a kind of Fall Guys game. So that's why I created the hammer, which can bump me. And I also created the hexagon that we can find in one of the map in Fall Guys. It's pretty good. And when I die, I come back. And I created a map. You can go and check it out. I have my hexagon level. And if I go there, it looks like the map in Fall Guys. I wanted to recreate it. And now if I play, I can see that it looks like the map in Fall Guys. And I can run, it will break everything. I can show you how I did the little animation. You see when I go on top of it, I have a little animation, the stuff go down and up and then break. I will show you how I did that. It was very simple. So I have my static mesh, which is just an hexagon. And on this, I have enabled the simulation generate hit. And when something hits this mesh, the hexagon, if it's a player, I have a timeline which go from minus 0.5 to plus 0.3 in 0.75 seconds. And this timeline just changed the relative location of the z-axis of my hexagon. So it goes down and up, and when it finished, it got destroyed. That's how I got this little effect. And now that I have the physical control and everything, it looks pretty good. We almost have a game. Now that my character is good, I will need to create some new animation. For example, the dive. And I would like to have an animation that be able to kick people. That could be nice to actually kick people. Okay, almost died. And then we just need to make a lobby, make the player to be able to connect to each other and to play the game and to create some new map. And then we'll be good with this little game. So it was very simple to create the physical control. The hardest part is to set up the rig and to set up the physical assets. And now we have a fully animated character that can react to the world with some of his bones reacting to the world. If you have any question on how to use the physical control, please ask in the comment section. I will try to help you. If it's a very complicated question, I can make a video about it. We almost have a game. The character can now roam around with the physical environment. There is some stuff, there is the hexagon level. We have some hammer that can push the player. We still need to create some animation for the character. We will do that on the next episode. We need to do a rolling animation, we need to do a dive animation, and I want to have some kicking animation because I want the player to fight with each other. I don't want just the player to be able to grab like in Fall Guys. I would like the player to be able to kick each other, maybe a punch animation, we will see. And then we will need to create some map. So we have to do some level design. We will try to do that together. I hope you enjoyed this video. If you like this video, please leave a like and subscribe if you don't want to miss the next episode for the game. And I will see you for the next video.